Hi everybody, I'm going to be talking to you about writing polynomials today. So we have been working a lot with solving and finding all the roots. What happens if you are already given the roots and have to write the polynomial that they came from? So we're essentially working backwards here. So the definition that we're going to work from is, so factors of polynomials appear in the form of x minus r, where r is the root if the coefficient of x is 1. We'll talk about when we have fractional roots as well in this video. So your factored form, as you guys know, because we've asked you to solve by factoring, is when you have x minus one root times x minus another root times x minus another root, however many roots that there are for your polynomial. Sometimes they don't always factor this way. Like you may end up with a quadratic that's not factorable, but generally speaking, this is how we would represent the factored form of a polynomial. Factored form of a polynomial does not include fractions when written with roots, so we do have to consider that, and we have specific instructions that will tell us that we do not want fractions with our answers. So first one, we're going to find a polynomial of least degree that has the given roots. Least degree just means we don't want to add in any extra roots beyond what we already have. We only want a polynomial that is based off of the roots that have been given. So we have a 1 with a multiplicity of 2. So we do want to consider multiplicity of 2. It means it happens twice. And then we have a root of negative 2. So we're going to write these in factored form based off of the root. Factored form is x minus the root. So the root of 1 translates to x minus 1. And since it's mult 2, it means we have 2 of them. And then we have our third root, which is negative 2. Negative 2 translates to x minus a negative 2, which is plus 2. So you are technically not done with this. You do want to work on foiling all of these out. It doesn't say in standard form, but a lot of your directions will say in standard form, which means that you do want to spend a moment once you get it in factored form to expand it to get to standard form. So if I expand my reds, so now that I've foiled out the red, I just need to foil or distribute the x plus 2. So this ends up being x times all of these components. So that looks like, and then the positive 2 times all of these terms. So you do want to make sure that you combine like terms at the end of all of this. So that is your final answer. So that is the polynomial that has the roots of 1 mult 2 and negative 2. All right, what happens when we have irrational roots or imaginary roots? How do we work with those? We still want to write it in factored form first, which ends up being, based off of the 0, would be x minus 0. Now you don't necessarily have to do this because you could just put x there, but for now I'm going to do that. X minus this root, and then x minus this root. Cleaning this up a little bit before we start foiling, we have x on the outside, and then in here we have x minus 4 minus I, and x minus 4 plus I. So you do want to consider foiling out or distributing out the factors that have the pairs, the i's with the i's, or if you're given radicals with the radicals, because if you start trying to multiply one of the factors with the i's with another factor that doesn't have an I, your work's going to get pretty messy. So you do want to do these guys, the i's first, and then work with the other factors. So we are going to power through this. We are going to do x times all of these, multiply everything by -4, then multiply everything by I. All right, so now we want to try to combine some like terms, maybe eliminate some things. If you ended up distributing this correctly, you're going to find that every term that has an I value or an I will disappear, will cancel each other out. So we have a negative ix and a positive ix, so those cancel. We have a positive 4i and a negative 4i. And then I squared, if you guys remember from the previous quadratic unit, I squared's value is -1, so we have a negative times a -1, so this actually turns into +1. So simplifying all this down, we end up with y equals that x that we never did anything with, and then we have x squared, say minus 8x, and then we have a +16 and a +1, which means we have a +17 back here. So one more set of distribution to distribute this x, and that is our polynomial that has a root of 0, 4 plus I, and 4 minus I. Okay, so we have a fraction root. Remember, we don't want fractional r's. So one of the things that we can do, we can think about this as if x is equal to 2/3, right? This is what you would get if you were to solve for x. So let's work backwards. Let's multiply by the denominator. So now we have 3x on one side and a 2 on the other, and then subtract the 2 from both sides, which then ends up getting us 3x minus 2 equals 0. And this value right here, the 3x minus 2, is your factor. If we were to set this factor equal to 0 and go back up, we would end up getting the root of 2/3. So that means that we have a root that looks like 3x minus 2. But we do have to make a note that it is mult 4, which means we have 4 of these. So let's work with these 2 at a time, just so that we don't get overwhelmed. So we'll group the first 2, and we'll FOIL out the first 2, which means that this second piece is also going to be that. And now we're going to multiply all the pieces. So we're going to take 9x squared and multiply it by all these guys. Multiply -12 by all of these. I am setting these on top of each other just because if I were to set them side by side, they would potentially get lost in my work. So I do want to make sure that I don't lose any of these terms. I'm just lining them up under like terms so that I can combine like terms a little bit easier. So now I'll do the 4 times all of these terms. And then the last step is just to combine all the terms to get one polynomial in standard form. So this would be the polynomial that has a root of 2/3 4 times.